Japan has a smart and innovative lander called SLIM, Smart Lander for Investigating Moon. But there's a twist. The lander landed upside down on the moon, and it went to sleep again as the sun set after 3 a.m. Japan time on March 1st. The Japan Aerospace Exploration Agency, JAXA, said on X, formerly Twitter, on Friday. What does this mean for the lander and its mission? Why is this so important, and what questions does it raise about the moon and the solar system? In this video, we will answer these questions and more as we explore the story of Japan's SLIM moon lander and its amazing achievements and challenges. You don't want to miss this, because this is not just a story of a lander, but a story of exploration, discovery, and innovation. So stay tuned and let's dive into the world of SLIM. The SLIM Moon Lander, which stands for Smart Lander for Investigating Moon, is Japan's first successful moon landing, which happened on Jan 19, 2024. The lander was launched on Dekdaus 2, 2023, aboard a Japanese HYA rocket, along with 2 other satellites. The lander's mission is to demonstrate a precise and soft landing on the moon, using a novel guidance and control system that can avoid obstacles and adjust its trajectory in real time. The lander also carries 2 cameras, a navigation camera and a spectrometric camera, to conduct science on the lunar surface. But things didn't go exactly as planned. The landing site for Japan's SLIM moon lander was Shioli Crater, an area filled with old impact rubble within the Mare Nectaris, or Sea of Nectar. The landing area is roughly 200 miles, 322 kilometers, south of Mare Tranquillitatis, the Sea of Tranquility, where the first moon astronauts from Apollo 11 touched down in 1969. During its final descent, the lander encountered a problem when it detected a large boulder near its target point. The lander attempted to avoid the boulder by changing its direction, but it ended up landing upside down on the moon, about 1.2 miles, 2 kilometers, away from its original target. This means that the lander's solar panels are crooked, but they can still receive a bit of power from the sun. The lander has been experiencing repeated severe temperature cycles due to the long lunar night and the sun shining above it, which increases the probability of failure. The lander plans to try operation again the next time the sun shines, which is expected to be in late March. Despite this setback, the lander has been able to communicate with Earth and send back some amazing photos and videos of the lunar surface. The lander has also detected olivine, a mineral that could be a clue to early solar system formation of rocky worlds like our own. This shows that the lander is not only smart, but also resilient and resourceful. But what does the lander hope to find and learn on the moon? The SLIM moon lander raises some fascinating questions about the moon and the solar system, especially about the origin and evolution of rocky planets like Earth. One of the main objectives of the lander is to search for olivine on the lunar surface. Olivine is a greenish mineral that is common in the Earth's mantle, but rare on the Earth's crust. Olivine is also found in some meteorites and asteroids, which suggests that it was formed in the early stages of the solar system, when the planets were still forming from dust and gas. Olivine could tell us how the moon and the Earth were formed, and whether they share a common origin. The lander's spectrometric camera can measure the reflectance and composition of the lunar surface and identify the presence of olivine and other minerals. The lander's navigation camera can also help map and characterize the lunar terrain and mineralogy by taking high-resolution images of the landing site and its surroundings. The lander's landing site, Shioli Crater, is a particularly interesting place to study because it is located in a region where the lunar crust is thin and the mantle is exposed. This could reveal the inner structure and history of the moon and how it differs from the Earth. The lander's cameras can also help us understand the lunar environment and its changes over time. The lander can capture the phases of the moon, the Earth's rise and set, and the lunar eclipses. The lander can also monitor the temperature, radiation, and dust levels on the moon and how they affect the lander's performance and survival. The lander can also observe the stars and the planets in the sky and how they influence the moon's orbit and rotation. The lander's data and images can help us appreciate the beauty and diversity of the moon and its connection to the Earth and the solar system. But what does the lander's success mean for the future of space exploration? The SLIM moon lander is not only a scientific mission, but also a technological and cultural one. The lander represents Japan's ambition and innovation in space exploration, and its contribution to the global effort to understand and utilize the moon. The lander's success can inspire and enable more ambitious and innovative lunar missions from Japan and other countries, such as landing on the far side of the moon, exploring the lunar poles, mining the lunar resources, and establishing a lunar base. The lander's success can also demonstrate the feasibility and benefits of a precise and soft landing on the moon, which can open up new possibilities and opportunities for lunar exploration and development. A precise and soft landing can allow a lander to land on a specific and safe location, avoiding hazards and maximizing scientific returns. A precise and soft landing can also allow a lander to land near a previous lander or rover and cooperate or communicate with them. A precise and soft landing can also allow a lander to land near a human landing site and support or interact with them. The lander's success can also showcase the creativity and diversity of Japan's space culture and heritage, and its respect and appreciation for the moon and its symbolism. The lander's name, SLIM, is a reference to the Japanese word for slim, which means smart or clever. The lander's logo, which depicts a crescent moon and a star, is a homage to the Japanese flag and the national anthem, which both feature the moon. The lander's landing site, Shioli Crater, is named after a Japanese poet and astronomer who wrote a famous haiku about the moon. The lander's mission, which coincides with the 50th anniversary of the Apollo 17 mission, the last human landing on the moon, is a tribute to the legacy and inspiration of the Apollo program and the moon explorers. In this video, we have learned about Japan's SLIM moon lander and its amazing story of landing upside down on the moon and going dormant until late March. We have also learned about the news and the questions it raises about the moon and the solar system, and the future plans and prospects of the lander and Japan's space exploration. We have seen that the lander is not only a smart and innovative lander, but also a resilient and resourceful one that can overcome challenges and make discoveries on the lunar surface. We have also seen that the lander is not only a scientific and technological mission, but also a cultural and historical one that can inspire and enable more lunar exploration and development, and showcase Japan's space culture and heritage. The lander's story is not over yet, and we can look forward to its awakening and operation and its continued contribution to our understanding and appreciation of the moon and the solar system. Thank you for watching, and please leave your comments and questions below.